Well, good morning, everyone. Welcome back to the Tin Barn. I'm Pragmatic Lee. Today we're going to continue in the series of the 2X by 72 belt grinder build. If you recall, in part 1 we looked at the creation of the rollers, the machining the rollers and putting the bearings in them. Part 2 we looked at the T-bolts and the corresponding nuts to go with them. The last part, part 3, was the structure itself and the welding with the hollow structural steel. In this fourth part today, we're going to look at the platen and the back plate, and maybe even have time. I think we may have time to look at the bearing block risers as well. So I'm going to get the camera in a little bit closer so you can see what I'm talking about as far as the platen and the back plate. I took the belt off, grinding belt off, so get a better idea of what we're looking at here. What I'm referring to as the platen is this structure right here, and the back plate, this black piece right here that the belt that backs up to the belt as it goes across these rollers. The platen and back plate, I've got this on a furniture dolly right now, the reason I can move it around, but the platen is held on to this piece of the structure through 2 bolts. One of them goes all the way through. Well, they both go all the way through, but one of them is stationary. The front one is stationary, and the back one is in this arc that you'll see we're fixing to mill out. The back plate is just a piece of 2-inch angle iron with some slots milled in it, one in the middle so we get access to the platen bolts, and the other 2 to mount it and adjust it. So let's take a look at the construction of the platen and the back plate. The platen on the belt grinder consists of 3 different pieces, plus the the mount for it. Right now we're just going to concern ourselves with one piece, the piece that the rollers actually mount on. The two rollers, obviously this will be mounted upright with a roller at the top and at the bottom. I'm using a piece of 1/2 inch by, I believe this is 3 inch by 1/2 inch by 12-inch long piece of aluminum. The reason I'm using this versus steel is, number 1, I've got it already. Number 2, you just don't find anything this size around the area I live in. Maybe if there was a welding shop or a machine shop somewhere around that was open to the general public like myself, they might sell me a piece. But as far as Lowe's, Tractor Supply, Fastenal, the biggest thing they had was only 2 inches wide and a 1/4 inch thick. Not something that I feel like is stout enough for this. But to mount the rollers on there, again, I'm using a piece of aluminum. It should be plenty stout enough for what we're doing. I want to round off all these corners just to dress it up. This piece is 12 inches long. I'm going to space the rollers 10 3/8 inches apart. So if I show you a little bit of how I'm coming up with my dimensions on this. Piece of material is 12 inches long. I'm putting the rollers 10 3/8 inches on center. So the difference in that is 1.625. If I divide that by 2, I get 0.8125. 8125 is what I'm going to mark off from each side here to find a point. We'll center that point up on the rotary table and then do our offset, which I'll show you how we compute the offset once I get over there. But then we'll turn this radius using the rotary table to clean these corners off. Alright, I'm over at the mill now, and I've got the piece laid out. I've got my 0.8125 from each of the sides, Now, I don't use the rotary table that often. As a matter of fact, I don't use it often enough to feel comfortable about showing you what I was going to do until I ran a trial. So I've already done one corner right here. But I've centered the rotary table up on the mill. I'm comfortable that's centered with the spindle. And I have the DRO set, so I'm going to bring it out here to the side just to get some working room. This plate that I have on the top of the rotary table right here is somewhat of a sacrificial plate. It's simply one mounted down in there, mounted to the rotary table with some mounting holes in it. So I'm going to set this up. And of course out here, I'm just getting it close. This mark that I have on here, we're going to want to get that exactly centered under the spindle before we run our offset. So I'm just going to snug that up now, just slightly. Now we'll bring the table back in. And on the DRO, I'm bringing it back in to where I set the 0, of where we were exactly on center. Now using the wiggler, now without touching there and without moving the table, we're going to get our piece and get that wiggler pointer right directly over where I marked our insertion. Now the key here is don't move the table. Move your piece to get it centered. And of course, keep in mind it's going to take several times, because tightening it back up may move it just a little bit. And of course, if you bump your wiggler while you're doing this, don't be bumping your wiggler, but if you bump your wiggler, you'll need to reset it. Now let me be sure this is showing to you. All right, recall we had the 0.8125 that we were come off of each edge to set up. The end mill I'm using is 1/4 inch end mill, so half of that's 0.125. So 0.8125 plus 0.125 means we need to offset our table 0.9375. So using the DRO, I'm going to offset on the Y 0.9375. Okay, just to show you what I've done, my X is still on 0, but I've offset the Y 0.9375. All right, I fully understand that for most of you that use your rotary table on a regular basis, this is elementary to you. But I did want to just point out for anybody that's not familiar with that, plus I wanted to talk it through for myself as well. So we'll remove the wiggler now and install the 1/4 inch end mill. Now I need to run the table down some. I'm sorry, run the head down some. If you're on a knee mill, of course, be running the table up. All right, that's got it close. Now we want to, obviously we want to conventional mill through that. So I'm going to bring it around to this edge. And remember I said this was somewhat of a sacrificial plate right here. And once I have that set in, just going very gradually and slowly, and I'm going to turn some air on this. I've got the siphoning hose out so I won't be picking up any coolant. And we're just bringing it 90 degrees, of course. Carry that down to the bottom now. And with a little bit of deburring, that corner will be finished. I'll repeat this process for the remainder, the other two corners on here, and we'll come back when we get ready to drill the holes in the center and put our radius in there as well for tilting. The four corners are rounded off now, dressed up. Now our rollers, if you can see, you may not can see it on there, but as a reminder to myself, I've just put a little circle on this side here. These are the ones that we will drill, and those will be drilled 1/2 inch for the rollers to set on. Now, offsetting from that, I found the absolute center of the piece, and again, using the wiggler, I lined up this piece with the center of the spindle, clamped it down good, and I've offset 1 inch. Now we're going to turn a radius over here. These two holes will be 3/8 of an inch bolts. This will be a 3/8 rigid bolt, and then it'll swing on this. We're going to put a radius over here. Now I've made a notation of the angle that the rotary table currently is, and I want to make a 90-degree sweep here, so I'm going to go 45 degrees on each side of that. And let's see, I believe I'll start from the other side. And I'm actually using a 7/16 end mill here just to give a little bit of clearance. I'm going to lock that down to get that initial start into there. Now while I'm right here, I should have set my DRO just so I know when I was coming close. But again, this is a sacrificial piece under here, so if I touch into it a little bit, I'm not overly concerned about that. All right, I'm going to lock the rotary table back down again, and let's see if I can't speed that up a little bit. All right, that's not quite through yet. All right, I just heard it break through on there. So this should be a cleanup pass. All right, our piece should be we should have our radius all the way through now. And we do. Little deburring on that. And again, this will have a hole in the center, and this will be able to tilt to get the angle on the platen. Alright, I'm going to think through, see if there's anything else I'm going to need a rotary table for before I take it off the mill. If there's not, we'll put the vise back on there and drill our roller holes and our center hole in the platen. I have the mill vise back on the mill now. Have the platen in the vise. As you can see, got a couple jacks under each end, so as when we drill and put pressure on them, we won't pull it out. Right now we're going to put a 3/8 inch hole through the center, and it's fine just to line this up with the pointer or with the center drill. Keep a little WD-40 close by. I'm going to drill this a 64th smaller than the 3/8 and then ream it out. I would like to have a reasonably good fit on this because this is where it's going to pivot. Now let's slow it down just a little bit. Alright, that should be all we need with the 3/8. The holes at the ends will be 1/2 inch. And just like the holes for the centerpiece, I'm drilling this a 64th under the 1/2, and then we'll ream it out to a 1/2. Alright, there'll be a couple more holes to drill in this for the backing plate that'll go behind the belt. That backing plate will be made out of 2-inch angle iron. And at this point in time right now, I'm 99.9% sure some gremlins have come and stole the piece of 2-inch angle iron that I had set aside for this backing plate. So until I can get it back from the gremlins or find some more, I'll have to take this out and work on something different for right now. I have our piece of hollow structural steel mounted in the vise now. This is the piece that this will pivot on from this hole right here. So we want to drill a 3/8 hole in the center, and I'm coming back 3/4 of an inch for the pivot hole, and then for the center hole. Then the pivot hole will be 1 inch over. Remember when we did this, we come over 1 inch from there. All right, I have the DRO zeroed out now. And just like drilling in here, I'm going to drill a 64th less than 3/8 and then ream it out. Alrighty, I'll see if I can round up a couple 3/8 bolts and we'll temporarily put this part together. Okay, here's a quick look at the plating so far. Just got the rollers in there now with a 1/2-inch bolt, way too long. And as you can see, it can set various angles with the plating based on that. And these will of course tighten down when get it in position. We still have our piece of 2-inch angle iron to go here that will serve as the backing for the belt itself. Alright, I managed to corner one of the gremlins and get them to tell me where the piece of 2-inch angle iron was, and they convinced me that they were just trying to help, and so they had cut it to length, and which is 8 3/8 inches long, and it also squared off the ends. So I've got it in the mill vise now, and I've got it center located, and we're gonna go 3 inches from center, and we're gonna mill a slot in this to 1.25 inches deep. So there's 3 inches. Now, being a piece of angle like this, I'm just not sure how much chatter and vibration I'm going to get in that, but we're going to sure give it a try here. I've got it slowed down a little bit. I'm at 600 RPMs. And just so I can see what's going on, I'm just going to use a little oil instead of trying to run the mister on it. Alright, I believe I'll speed that up. Alright, I am going to blow a little air on that, get those chips out of the way. And I've got a mark back here at 1.25 inches. Now we're going to come to 3 inches on the other side. Alright, I'm going to get this deburred. I'll get the plating put back in there and the drill chuck in. Then we'll drill and tap the matching holes for these. I have the plating back in the vise now. Got the chuck in. I've got the first hole located. And we're going to drill and tap this for 3/8 16. I believe that's what it is. Yes, 3/8 16. Alright, I've got the x-axis zeroed out. So we're going to come down 6 inches from that. And of course our y-axis shouldn't change. Alright, we're going to see, or I'm going to see if I can power tap through this aluminum.
Alright, now we'll come back to our zero on the DRO. I think we pretty much got a plating done right here. Deburr this a little bit and carry it back to the workbench and see what we got so far. Alright, here's the two pieces of the platen, of the platen system. We have the platen right here and the backing plate for the belt. As you can see, I had to make one more slot in there for this center, for that center bolt, pivot bolt on there. And the backing plate itself can be removed if you desired to have a soft belt in there where you were pushing, doing a contour on a piece. All right, I think we got a little bit of time left in this video, so we'll look at the risers for the bearing blocks. Now, I used, if I had had a motor high enough RPM, I would have put the drive wheel directly onto the motor. But this is only a 1740 RPMs, and I needed about 3,400. So with the pulleys that I have in here, I stepped the speed up. Of course, that cut my power down a little bit, but but that increased the RPMs to what was needed. In order to do that, I needed to use some bearing blocks and a shaft, which we'll look at in the final part 5 next week. But right in this video, we're going to look at the machining of these blocks right here, these pieces of 3-inch angle to raise up the bearing blocks. All right, I'm around on the back side of the belt grinder now. Got the camera around here. This is what we're going to use for a drive pulley. The motor I've got is a 1.5 horse motor, 1.5 horse, but the RPMs is not quite what I would like to have. It's a 1725 RPM. And what I want to do is speed up the RPM. I believe with a 1.5 horse I can stand to lose a little power to get the RPMs up. I'd love to get around 6,000 surface feet per minute. And working with the pulleys on the motor and the shaft here, and then this, I'm starting with a piece of 8-inch aluminum, 2.3 inches thick. But what I'm going to do is, I've laid out the shaft now, or I got the shaft where I think should be right. I've got a couple of stop blocks picked up from the local farm supply store. Be sure I got this in frame. They're simply collars with a grub screw on the side of it. There'll be one of these on each side. Now I'll be putting a keyway on this and a keyway in the drive roller. But there'll be one of these collars on the inside and outside, because I will not be able to drill through there to put a grub screw in the drive wheel. So with a keyway, we'll keep it concentric with the shaft, or turning with the shaft, and these collars will keep it from moving in lateral direction. I'm seeing from this mock-up that I've got back here, and then again, this is not setting where it will in its final destination. This is just on my mock-up table right now. But I can see I can put this bearing block in line with the back here. My shaft is long enough that I can, this is a piece of 10-inch stock right here. I can maneuver it a little bit either way if necessary to keep this on center with the rollers, which we've already got centered up. I've got a 2-inch gap between the lockdowns on the bearings, on the two bearings, and then we'll have a shaft down here. And working between the pulley on the motor, this pulley, I should be able to get around 6,000 surface feet per minute, which is what I'm looking for. I'll have to turn the diameter down on this just a little bit to be sure I got clearance on the final table that it's set on. But I'm going to move over now. I think I've got this like I can take some measurements off of. To get the pillow block bearings up a little bit higher, what I'm doing, I'm using a piece of 3-inch channel iron. And we all know that channel iron has a bevel in here, which is very difficult to seat a bolt on. And I'll be using this, of course, bolting through it to mount it to the table and to mount the bearing blocks. So what I've done on this one already is just simply carried it over to the mill and milled these surfaces flat on the end right here. Got a deburr right there. But that'll give me a good flat surface for the bolt heads to mount to. So I'm going to move the camera back around to the other side and to the milling machine. We'll do that get our flats on this other one right here, and then we'll also drill some holes. While we're over there, we'll cut the keyway in the shaft, and we'll also mount this in the lathe and get it faced and get it drilled to match the shaft. To get our flats on the inside of the other piece of channel iron, I've got it setting in the vise now and just got it centered by sight. Again, all we're looking for is a flat surface in there big enough to get the pillow block bolts, a flat place for those, and a flat place for the mounting. I've got my depth already set from the other one, so I'm simply going to bring this in and I'm coming 1.5 inches from the end on each of the 4 sides. And then I'm simply going to move it over about half the width of the end mill. Continue that process. Once I get that done, all of them, then I'll come back to the starting point and conventional mill it out just to get a finished surface on there. Right. I'll continue that process on the other 4 corners. I've got all the internal flats milled on both pieces of the channel iron that'll be used to raise the pillow blocks with. And now I've got the holes laid out, and I'm just going to drill those, each one of them. And I'm actually going to drill these 64th over the 3/8, simply so I got just a little bit of wiggle room mounting them down. And again, all this is for a mount. So I'm going to go through and drill all 8 of these holes, 4 on each side. All right, now I'll deburr these, and they should be ready for the for our paint job and bearing block risers, be used as bearing block risers. All right, that's going to be a wrap for part 4. Next week we'll look at part 5. Part 5 will be the conclusion of this. I appreciate everyone sticking with me through this. But in part 5, we're going to look at the drive roller itself right here, the large drive roller. The bushings, some little bushings that I had to machine to hold the rollers, to mount the rollers on their axles. We'll also look at the shaft back here that the drive wheel is mounted on.
and then we'll take just a few seconds and look at the assembly of it. So keep a watch out on the channel. Again, I appreciate all the subscribers, appreciate the comments, and we'll see you next week.